Hello, welcome everyone. We're just going to wait about a minute for people to join the webinar, and then we will get started shortly. Okay, hi everyone. Welcome to today's webinar on what the ISO 14090 standard means for building climate resilience in Canada's transportation sector. My name is Laura Zimmerman, and I am a policy analyst on the climate change adaptation team at Transport Canada, and I will be your moderator today for today's webinar. First, I would like to acknowledge that I'm speaking to you today from the traditional unceded territory of the Anishinaabe Nation. I invite you all to introduce yourselves in the chat box if you would like and include your own land acknowledgement. I'm just going to go over a bit of housekeeping before we get to today's speaker. Claire Sanders from the Climate Risk Institute is your technical support person for the webinar today and will be available during the webinar if you run into any audio or technical issues. If you need assistance, you can click on the chat box and find her name in the drop-down menu of participants to send her a direct message, or you can send a message to host and panelists. There will be a dedicated Q&A session at the end of the webinar, but that doesn't mean you have to hold your questions until then. Please feel free to type out your questions during the presentation in the Q&A box, and the chat box is also available if you would like to submit comments. We are recording the webinar today, and we'll be sending out a link to everyone who has registered, along with a copy of the presentation slides. The webinar today will be held in English, but we will share French versions of the presentation slides on the Climate Risk Institute website in the next couple of days. This webinar is part of Transport Canada's Transportation Adapting to a Changing Climate webinar series, and we'll have some more information on our next two webinars at the end of today's presentation. So now I'd like to introduce our speaker for today's webinar, Professor John Dora. John is a Royal Academy of Engineering visiting professor at the University of Birmingham and a visiting professor at the University of Surrey and a fellow of the Institution of Civil Engineers. He's a recognized international expert on climate change adaptation, standards, and sustainable infrastructure asset management. He has over 30 years experience in infrastructure, including flood risk management and asset management of railway structures. His career has covered research, construction, and maintenance of civil engineering infrastructure, and he has become an acknowledged expert in resilience. So on behalf of everyone joining us today, I'd like to extend a warm welcome to John for presenting this webinar for us today. And without further ado, I will now turn things over to John.
Thank you very much, Laura. And I'm just trying to set up the share of my slides, which seems to have actually caused me a bit of a problem just now. I had them all set up. They seem to have disappeared. I'm just going to get everything back on the same screen and have a go with this. I do apologize for this.
I'm happy to jump in, John, and I can share your slides for you if that helps.
Yeah, I think that'd be just one more try.
Sure.
I can see them there. Yeah, just one more try. Bring them up.
Yeah.
Zoom. A new computer. This is a problem. Just there we go. Is that them there? How's that?
Yes, we can see them.
That's great. Right. I'll start at the beginning. Sorry about that, but here we go. Yeah, I'm going to talk about ISO 14090, a standard, an international standard. I had the privilege of being the convener for the working group that drafted it. It was published in 2019, almost 4 years ago, and it seems like just yesterday to me. This is a webinar with case studies, and it covers a number of topics centered around ISO 14090. So I just want to get into, first of all, the importance of adaptation to climate change for an organization, a transport organization in particular. The business case for adaptation, people keep asking me about what's the business case for adapting to the future climate. Well, the business case is getting stronger, and people at the World Bank have come up with figures like for every dollar invested, you get $4 benefit investing in resilience, in investing in adaptation. I think also as well about things like the supply chain, value chain resilience, which is something very much overlooked. People think about their own operations rather than what's happening outside that system. There are things like accountability, liability, organizational reputation that come into play. And of course, adaptation is very much a risk management exercise, managing future impacts by doing something now to adapt to the future climate. It improves business resilience in the much longer term. An adaptation using 14090, which I use as a shorthand for ISO 14090. 14090 supports 14001, which is the environmental management standard. That's the second biggest selling standard in the globe, that standard. And it supports asset management, 55,000, which is quite an important one in my field, having worked all my life in asset management and infrastructure. But I also say here, wouldn't it be good to have a framework to help all this? And in that sort of line of thinking, I come back to other drivers for adaptation, international initiatives. I pick up here the Paris Agreement, which we all know about from 2016. Again, that seems a long time ago. Article 7 of the Paris Agreement is about adaptation. Capacity building is mentioned, and part of ISO 14090 looks at capacity building, and I come into that much later on. And of course, Sustainable Development Goals is SDG 13 about climate action, and lots of others that are mutually supporting adaptation, resilience building. And in more recent years, TCFD, the Task Force for Climate-Related Financial Disclosures, has come on stream, and we're seeing people asking questions about how you declare your resilience using the TCFD protocols. International initiatives, national initiatives, because every country signed up to the Paris Agreement and the SDGs. Out of that, we've got nationally determined contributions, adaptation reporting, and policy changes that come out of governments, all related to the Paris Agreement, cascading down, of course. Business drivers, I mentioned risk management, and we think of flooding, earthwork stability, drainage, linear assets like roads and railways. You've got tracks and roads that are all impacted by drainage and flooding and heat. But we mustn't forget about the workforce and passengers and how heat and cold can impact them. We look on things like electrified railways. We look at wind affecting the overhead current line. Around coastlines, we look at sea level rise. There's a whole host of other hazards that we think about in terms of risk management. But risk management is all about looking at the infrastructure and the systems there, but we think also about multiple stakeholders' interests. Who are using the transport network? Who's got interests here? What do they need to think about? And I put here, consider things like infrastructure life cycles, systems thinking, and the interdependencies between different components of a transport system and wider. And I touch on these topics later. And the business case, like I just mentioned, is continually getting stronger as the climate changes, and the climate is changing more rapidly than we thought 5-10 years ago. Another driver, economics. I mentioned the World Bank study that looks at $4 benefit for every dollar invested. And I bring back these comments here: reputation, service resilience, value chain, supply chain resilience, accountability, liability, and infrastructure interdependencies. Some of these things come back and time again when looking at adaptation and resilience. And I bring back this point. 5 or 6 years ago, I've been working in this field since the early 2000s. 5 or 6 years ago, I was thinking that we'd be seeing evidence of the climate changing impacting on infrastructure and transport networks, maybe in the 2040s, perhaps in the 2030s. We're seeing the evidence now with rapidly changing climate. And I've seen floods and heat waves in Canada. I've seen floods and heat waves in Europe, and all around the world, we're seeing extremes, records being broken, and increasing frequency of extreme events and that sort of thing. The climate is changing rapidly. There's a huge case for getting on with adapting our transport networks. Now, some of the things I'm picking up and what we've included in the ISO are things like systemic adaptation. It's seen as best practice. And ISO 14090 talks about looking at an organization as part of a system and how you look at the whole system. You can't just, to my mind, you can't just look at what you're controlling. You've got to look beyond that. And governments, engineering institutions, the Royal Academy of Engineering in the UK are all picking up these themes and saying to people, we need to think about how transport systems, infrastructure systems interlink and have that dialogue between different components of these systems to make sure that we think of the weakest links and bolster them in the face of a changing climate. System thinking considers the whole system, external influences, interdependencies, and interconnections. And by them, I'm thinking of things like external influences could be weather, or it could be a hazardous climate event or natural event, which might be across the other side of the globe because our supply chains are that long. Interdependencies can be things like fuel supply to vehicles on a transport system, aircraft, trains, trucks. Interconnections could be things like information communication technology and energy to run the supervisory control systems, traffic control, railway control and dispatch, air traffic control. So these all are part of the whole system, and other elements of the value and supply chain. Like I mentioned, we get components from the other side of the globe very often, and we're very much into just-in-time delivery of components, which can be a problem when we have an event where we urgently need something and that component is thousands of miles away. So it's just some thoughts I'll pose there, an urgent need. But also part of the system is the governance and leadership of the organization, financing, and I call soft concepts like policies, strategies, and plans. They're all fundamental to building resilience and building adaptation in the longer term. You need the policies, you need your strategies, you need your plans to deliver adaptation. And phrases like policies, strategies, and plans come out of documents like ISO 55000, the asset management set of ISO standards. Being a standards enthusiast as I am, I like to use similar phrases in different areas. And also, you know, the urgent need, we're coming back to Paris and UN SDGs. These give a top-down sort of focus on why we need to adapt and give us the impetus to say to our leaders that we need to adapt because we've signed up to adapting through the Paris Agreement. Forecasting, contingency planning, maintenance, all part of building resilience. And of course, future-looking technical standards are crucial. In Europe, we use the structural Eurocodes, which are about 20 years old now, for the design of infrastructure. And most countries in the European Union have laws that say if you build public infrastructure, it must comply with these technical standards. I've been working with the standards committee that's responsible for these technical standards, and over the next sort of couple of years, they will be modified to help designers look at the future climate. The problem with them just now is that many of them look at the 1961 to 1990 climate, which is not actually what we've got in Europe, anywhere in the world today. It's a different climate. So you must look at the future for technical standards. Another thing I think about in terms of looking at adaptation and resilience building is to change the mindset. I've worked in infrastructure maintenance, both in railways and in flood risk management in my career. And most of the time, we're concentrating on cost. Now, cost is a concept. The first initial cost is something that drives, to my mind, lots of project engineers to pay costs for the first initial cost. But if I look at things like ISO 55000 and other good asset management practices, I start looking at whole life value, not at cost. And something that might appear expensive, and that's a subjective term, expensive, something that might appear expensive when you're designing and building something might add value over the longer term. Something built in to make a set of assets easy to maintain, for instance. They might cut that. People might cut that out of a project and make it cheaper for delivery. But being a person who's cut his teeth on maintaining lots of ancient 200-year-old railway assets and 50 to 100-year-old flood risk management assets, maintenance to me is the thing you need to invest in. And the maintenance and operation of infrastructure, of transport assets, is giving you the sort of early warning as to how things are behaving, how things are deteriorating. And that's something we need to think about in terms of climate change. So just a couple of things here. The World Bank, again, talks about investing in regulations and planning in the early stages of project design and in maintenance. And they're talking about how, with disaster resilience, building in good whole life thoughts and maintenance in the project design phase is really good practice, because it can outweigh the cost of repairs. Design things to fail gracefully, not to fall catastrophically, which is what I think we've seen recently in Turkey and Syria, sadly, with corners cut and infrastructure collapsing with an earthquake when things should have been more robust. 2/3 of the infrastructure needed for 2050 is yet to be built. Again, the World Bank brought this up at COP22. So if we've got to build something, let's design them with the future climate in mind. There was a climate change risk assessment figure in the UK 2 years ago that said investing in adaptation can pay back up to £10 for every pound spent. So the World Bank is saying 4 times as much. Climate change risk assessment is saying up to £10, up to 10 times as much. There are drivers there for spending money on resilience building. Change the mindset, think value, not cost. Whole life cost, not lowest first cost. And challenge economics theories. This is something I talk about quite a bit to my students and others. Our economics theories are based on future generations being able to afford more than current generations because of this concept of growth. Now, those of you who are into sustainability will probably realize that we haven't got much in the way of resources, natural resources, that we can count on to sustain that growth in the longer term. So I think the current economics theory is looking at high discount rates and financial calculations over 20 years, that sort of thing, are not actually valid for looking at long-term future resilience of any infrastructure, transport infrastructure. We need to think, I think, we need to think more of the triple bottom line in sustainability terms, looking at, okay, the dollars, look also at society and look also at the environment. We've got to balance things and get away from this idea that future generations can afford more than current, because past generations have used up our greenhouse gas carbon budgets in many ways. So they're just some almost provoking, thought-provoking thoughts from me. Put that to one side, come round now to the main topic. ISO 14090, 2019, Adaptation to Climate Change, Principles, Requirements and Guidelines. It's a standard. Now, the case for using a standard is around how a standard sets out an agreed way of doing things. And it's built up, drafted by professionals. Any standard has a working group who are professionals experts in their field, so you can trust what they're writing. 1490 was written by adaptation professionals, and it can be used to demonstrate international best practice to others. And let's say clients, investors, legislators, and many more. I hesitate very often to use the term best practice, and I usually use the term good practice. But in standards development, things like ISO 14090, because of the rigor that they're produced with and the expertise and the checks and balances, I'm happy to call that international best practice. 1490 had 7 meetings to iterate the final version. Each meeting was a full 4 days of full days, and there were sort of subgroups outside those 7 times 4 day meetings to draft the text and agree it between the team that were doing that. So there's a lot of work gone into that to produce international best practice. It's a recognized benchmark. Here's something we can aspire to. Are we doing our planning, our capacity building? Are we monitoring, evaluating, and reporting in a certain way? And the standard, because it's international with an agreed set of terminology, it can be used across different sites, different levels of organizations, nationally, internationally, locally, to provide consistent results with consistent terminology. People understand they're talking about the same things, the same concepts. And the other thing I would mention is, and I think there was a question earlier in the preamble to this webinar, can we use the standard to give accreditation to organizations? And it can form the basis of an accreditation process. I've yet to see an organization being accredited to 14090 because it's all about producing an adaptation plan. But if somebody came along and asked to have an audit process, an accreditation process against a plan that's been derived from 14090, I'm sure that's entirely possible, because the way we drafted it was in a way that has enough in the way of requirements, the shall clauses, that could allow people to take it and tick the boxes to say they've done that, they've proven they've done that, so they can have an accredited adaptation plan. So, snapshot of why we use standards. Now, understanding climate risks in your own field. I'll talk a little bit about vulnerabilities and some of the information that's come out of the Intergovernmental Panel on Climate Change. And the picture's not good. The studies with the evidence show everything rapidly changing this century to some quite alarming future climate scenarios. And we're talking of something in the region of maybe, looking at the way things are going just now, maybe a 3-degree, 4-degree rise in temperature by the end of the century compared to pre-industrial levels, which is really bad news, because we were trying to keep temperatures below the 1.5 degrees, as we know from the Paris Agreement. And that's something that means that there are more risks and impacts on transport systems, on infrastructure systems, on society in general. And even if we stop all greenhouse gas emissions today, it's going to take a few centuries to stabilize temperatures. CO2 stabilization in 100 to 300 years on this slide. And sea level rise is going to continue for several millennia. So we're going to see meters of sea level rise over the next few 100,000 years. We know the climate is changing. We need to think about reducing greenhouse gases, but we also need to think about this field here of risk and vulnerability. And we also recognize that risk is influenced by understanding and capacity. If our decision makers understand how the climate is going to impact our infrastructure, the assets, how they might behave, we can build capacity into the assets to make them more robust. But we also need to build capacity in decision makers to train them to understand that some of their decisions might have a long-term impact and we build transport assets to last 50 to 100 years. And like I said earlier, I've worked on railway assets in the UK, which is where I'm based. I've worked on railway assets in the UK that go back to the 1840s, 1830s. So you can build things with a design life, but you can keep them going for a long time if you maintain them properly. But you need to think about the future climate as well. How is that going to impact on assets? We're very good at projecting future temperatures, future climates, future humidity, and less good at sort of working out exactly how much rainfall or how many days of heat we're going to have. We know it's going to happen, but we're even less equipped in understanding how these future climate hazards are going to impact our assets, our infrastructure. And that's an area that I've been working with in the UK, with mainly the rail industry and one or two other industries, energy included, in looking at how future climate patterns will impact things like earthworks, cutting slopes, bridges, and railway tracks and road blacktop and that sort of thing. So there are certain areas where we're good at looking at future heat impacts, say on railway tracks, buckling, bending in the heat, but extreme rainfall on an embankment that was built by about 1845 is a difficult thing to look at. So some good understanding, some not such good understanding, but by having some of this knowledge in our decision makers, it can help us improve how we react to the future climate. So vulnerable infrastructure, thinking about transport, and the diagram here comes from Hurricane Katrina. It just shows a number of these interdependencies between different parts of infrastructure systems that can have huge impacts through cascade failures. If your power goes down in a transportation system, you might think, yes, we can't run trains and our traffic control in the cities is not going to work. But how do you communicate with people if you can't get power to your comm system? These things need to be thought about. Contingency plans are there. They will be a good thing to have. But thinking transport infrastructure, what do we have? We've got terminals for freight, for passengers. We've got interchange hubs around airports and around transport hubs in cities, in the urban environment, where you can change from automobile cars to trains or to air travel. We've got linear corridors like roads and railroads have, and we've got system needs. We need people to maintain, operate, and respond to what's happening currently and plan for the long term. We've also got the need for energy to power all our comm systems, ICT, information communications technology, vehicles. I mean, we're looking now at electric vehicles quite a lot for the road network, and we need to change the energy system for charging those. So there's lots and lots of interdependencies, and many of these infrastructure components can be vulnerable to future climate. They're all connected as systems, but if you imagined if you've got a freight depot or a passenger train depot that gets flooded or knocked out, the power gets knocked out, you might end up with all your trains locked in a depot and unable to perform. And how does that impact the transport system? How does that impact the economy? How does that impact the sort of longer term resilience of a region, of a country, of an urban system? All these things need to be thought about. What's vulnerable? Can you identify what's vulnerable? And how are they interconnected as systems? And I talk about systems quite a lot. I keep talking about it. And this is a diagram from a friend of mine, John Beckford, who in a paper for the UK government about, what was it, 2000, about 20 years ago, showed how society needs defense, health, commerce, education, and these sort of systems are all underpinned by infrastructure, transport, water, waste, energy, ICT. So transport's a vital link in the whole sort of operation of society. So that's a rundown about future climate standards, systems thinking, and one or two other areas being into transport. Let's look at ISO 14090 and adaptation plans now. ISO 14090 is not a standard that's been designed for just one organization and it brings one way of doing things. It's written in such a way that it's applicable to any organization of any size, of any sector. And depending on the audience, and because I live in England, I tend to point out it could be applicable to a cricket club. And actually, last year I had an inquiry from the English Cricket Board about cricket, which is really bizarre. How's climate change going to affect cricket? But that's another thing. But any organization, I show a picture here of a flood on a railroad, which is about 15 kilometers from where I live. And that brown water there is a river called the River Evenlode, which is normally quite a small brook at the side of the railway. In 2007, it had a 1 in 250 year rainstorm and it washed out the railway. Railway was closed for 6 weeks. So I couldn't go up to London as easily as I used to for that time, because this is a line that I take into London. But it's applicable to organizations, any organizations, ISO 14090. It's designed to be flexible so it suits your business. It asks questions for you to work out the answers to. It doesn't say do this, it says, how do you do X, Y, Z? And it can be used at any stage of adaptation. We've been doing some work recently for the French Environment Agency, looking at adaptation in 13 companies, from mature companies that have been doing adaptation for some years to one or two just starting out. And ISO 14090 works no matter where you are on your adaptation journey. It allows you to, or guide you to produce risk or vulnerability assessments depending on how you prefer to do impact assessments, and enables tailored solutions, not one size fits all. So questioning the process of going through 1490 allows tailored solutions suited to your organization to be developed. It's an iterative process. It's not a linear one. Those of you who might be familiar with 14001 goes through plan, do, check, and act sort of cycle. 14090 is not like that. 14090 is one that you can start any place and work out and back. So you can look at maybe impact analysis and look at planning and then go between them and learn and build things in there. So it's not linear, it's iterative, and you can bounce around the standard. I've got more details coming up in a second on that. And what I've also got to pick up is that a theme is, don't make adaptation a special project. It should be business as usual. You might have to have a special project to produce an adaptation plan, but all those plans and actions should be embedded in the business as a normal business process. And of course, like I've said before, it's linked to Paris and the UN SDGs. So some of the key elements in 14090, at the outset, in clause 5, we call clause 5, and we'll go into clause 5 in a minute. Clause 5 is a pre-planning clause where we actually look at the fitness of the organization to embark on adaptation planning. And we ask questions on the governance of the organization, the leadership and awareness throughout the organization of adaptation and resilience, questions on life cycles and length of decisions. If you make a decision on something now, is that going to impact for 5 years or 20 years or 50 years? Questions like that. And more detailed questions go into things like the organizational capability. What kind of knowledge is there in the organization? What kind of resources have you to build an adaptation plan? And then there are parts on the ability to assess impacts and understand what the impacts are. And of course, I come back to the systems thinking part, cross-cutting or systemic matters. So these are key elements that come up very early on in the standard. The main sections in 1490, typical of a standard, is an introduction, there are some principles, There's a whole section there on terms and definitions, but the meat of the standard is clauses 5 to 10, pre-planning, assessing impacts, adaptation planning, implementation, that's implementation of that plan, monitoring and evaluation, and reporting and communications. And these, like I said earlier, these took 7 4-day meetings to put together and refine the wording. The actual standard comes up for review next year, and there's probably 1 or 2 little changes to be made, but in principle, everything will stay roughly the same as it is now, as I see it. So pre-planning, clause 5, it requires an understanding of the organizational capability to form an adaptation plan. So it's like a pre-check. Is the organization fit to carry out a plan? Has it got the right governance, leadership, resources in place? It prepares the organization for adaptation planning, and it asks the organization to gather information. It asks you to look at clauses 6 to 10 and work out whether you can deliver 6 to 10. 6 and 7 are key: impact analysis and adaptation planning. And of course, being an adaptation planning standard, any sort of gaps identified in clause 5 require a plan to fill those gaps. So it's a nice early step to go through and find out if you can actually produce a plan. And my company, Climate Sense, actually provides a service looking at clause 5. We do lots of clause 5 analyses with many organizations to work out what they need to do to build the resources and capacity to produce an adaptation plan. Clause 6, it talks about climate change impacts. It doesn't talk about carrying out a risk assessment or a vulnerability assessment. It doesn't require those. It gives you guidelines that you may carry out risk assessment, or you may carry out a vulnerability or a threshold analysis. And it doesn't lock in an organization to any one method, because I found, or we found when we were drafting the document, that it was very important to give organizations the flexibility to use the impact assessment method that they're accustomed to. We talked in there about things like vulnerability analysis, and looking at hazard times vulnerability times exposure. We also talk about risk assessments that look at likelihood or probability times consequence or impact. So there are different ways of looking at impacts. And since we drafted 14,090, 14,091, one of the suite of standards supporting 14,090 gives you more detailed guidelines on carrying out vulnerability assessments in line with the IPCC way of looking at impacts and vulnerability. So clause 6 is fundamental. Clause 7 as well is fundamental. It talks about assembling the plan from the clause 6 work, from varied sources of knowledge in the context of your existing policy, strategies, and planning. So that sort of brings in this concept again of looking at decision-making processes and making things business as usual embedded in the organization. So adaptation planning talks about the planning process and gives you some, clause 7 talks about the adaptation plan and gives some headings that the adaptation plan has to address. And again, you're assembling this plan from what you've done before. You've done an impact assessment with clause 6. You've done the pre-planning clause 5. Clause 6 covers quite a few other areas as well as impacts. So it talks about policies and other areas too, and linking things back to corporate policies and the like. Clauses 8, 9, and 10. Clause 8 is taking the adaptation plan and then actually go into a bit more detail to make sure the actions identified are delivered. So an implementation plan, which includes things like support from senior management. Because if we don't have that support from senior management, we thought you probably won't get the adaptation plan delivered. So we actually required a way of demonstrating support from senior managers in clause 8. We also brought up in clauses 7 and 8, the concept of having indicators that can be monitored and evaluated, indicators linked to the long-term trajectory of the adaptation plan. And one of the things I want to do when we have the next issue of 14,090 is maybe change that word trajectory, because it's a difficult one to get your tongue around in a presentation like this. But the idea of trajectories is that you're not able to prove you have adapted your organization in 1 year or maybe 5 years, but you need indicators that show you're on the right path to deliver that adaptation. That's why we use the term trajectories. Monitoring and evaluation, again, is quite obvious. It's assessing the progress of your adaptation against the implementation plan. And again, you'd be looking at those indicators to see if you're on track. And also when you evaluate the progress, there are clues in there, there are guidelines on how to change the plan if need be, if you're not on track, or change the plan if new information has come about. If the climate projections make things look worse in the longer term, or if climate projections make things look better, or if there's a new technology, these things can be built into the plan through the evaluation process. We're very much into learning in adaptation planning, and having the processes in place in an organization to learn from what you've done and build that back into the sort of next generation of adaptation planning modifications. And clause 10, the last one in the document, is about reporting and communications. And there's guidelines in there about what to communicate, whom to communicate with, and the best way to do so. Lots of guidelines on how to involve interested parties and stakeholders. Of course, some organizations might not want to communicate adaptation plans, but that's fine. We don't require communication. We say that if you do it this way. So that's a rundown of the contents of 14,090. I just want to go through some of my thoughts on 1490 in particular. So how, in your organization, in a transport organization, how well are future impacts understood? Extreme weather is something that we're quite used to in many ways, but slow onset climate change, how could that impact your organization, your services, your transport services? One of the things I've been looking at in the UK and in Europe has been slow onset change of sea level rise, which is one thing, but how vegetation species are changing and migrating and moving north as things are cooler in the north. How will changes to vegetation growth impact on a railway, for instance, the security of the overhead line? Trees dying out, then blowing over onto the overhead line that carries current, or blocking roads, that sort of thing. So some of these thoughts have come about with looking at slow onset climate change. Another question, do you know how you're exposed to weather hazards and changing weather hazards? Are they direct on you at your depots or via your suppliers? Supply chains, I mentioned that earlier. Are long supply chains resilient to weather patterns? I know it wasn't a weather-related incident, but if some of you remember the nuclear power plant in Japan at Fukushima that was knocked out by the tidal wave, that had major impact on Japanese industry, but it affected the car building industry only 50 kilometers from where I live here in England. There's a Honda factory that was put onto short time and stopped building cars because 6 weeks, 2 months after the tsunami, they weren't receiving components from Japan. That long supply chain was affected by a natural hazard thousands of miles away. So the standard actually asks you to think about some of these things. Have your assets been designed for the future climate? This is one I've alluded to earlier. You know, are the existing standards fit for the next 30 years or 5 years or 50 years, depending on the life cycle of your assets? Electrical equipment in communications technology might be 5 or 10 years. 30 years for a railway track system, or maybe a road blacktop. 50 plus years for bridges, culverts, and retaining walls, tunnels, maybe 200 years. You know, how will these assets that we've got fare in the future climate? And if you're building new ones, can you design them for the future climate? Yes, you can. You don't have to follow exactly what's in design codes. You can look at future climate and design for those. So some more thoughts, and I think this is very important. I'm finding when I speak to organizations about adaptation, that many of them don't want to do anything because the decision makers at the top aren't aware of the topic. So governance needs to change. Leadership needs to understand the issues. And one of the hooks I use there is that I point out that the countries signed up to the Paris Agreement. So that needs to filter down into how we manage our organization now. And that needs to be sort of brought to the attention of decision makers with this sort of whole life value concept in mind. So standards, 14,090, challenges. We found very much in our, well, my company's found very much, the standards are great tools, but many organizations only use them if they have to. So does legislation force organizations to use a standard? And sometimes it does, like the design codes in Europe for public infrastructure. But if lenders, banks, investment banks are building infrastructure for 20, 30, 50 years in the future, then they can introduce conditions to the loans to say, make it compliant with ISO 14090. And does the system framework require it? Are we managing our assets in a sort of best practice way using ISO 55,000, for instance? If you use 55,000, I firmly believe that if you're looking at long life assets, then you will be almost required to pick up 14,090 to look at future climate risks, because that's good asset management practice. I come back again to the structural specifications, based on historic climate in Europe generally. But I've got a couple of guides here. CEN, European Standards Body, and ISO produce guides on looking at future climate in design standard. And there's a later slide with a link to these. The other thing I pick up on is when you design infrastructure, you tend to design infrastructure for a design life and bridge maybe 120 years, or a drainage system maybe 60 years. This design life concept, I think, brings in uncertainty issues, because I wouldn't be confident in designing a drainage system now for 60 years' time if it's got a 60-year design life. And that brings about, because of uncertainty, a reluctance to invest. But there are tools to get around that by looking at things like adaptation pathways, which I'll touch on as well, other approaches. So some of the opportunities in looking at transport and planning policy: avoid developing in exposed areas. And that's something that's come out of disaster risk reduction as well. Don't build in exposed areas. Don't build in eroding land around the coastline or in mountainous areas if you can. Don't build in floodplains. Review long-term infrastructure policies and strategies. Think system and the interdependencies. Consider issues across all these interdependencies in terms of how robust will your transport system be if the energy system isn't robust. Need to think about these, think about supply chains, think about governance. Now, managed adaptive approach, this is something that can be used using adaptation pathways. TE2100, by the way, is the long-term strategy for the tidal defences that protect London, the capital city of England, which faces tidal surges every so often. And the Thames Barrier and the tidal defences were inaugurated, I think, about 1984 to protect London. And it took about 30 years to get that system in place. They're looking over the next sort of 80 years as to how they will evolve that tidal defence system, with sea levels rising up to about 1 metre by the end of the century. And the practice that was used to derive the strategy for this Thames tidal defences, Thames Estuary 2100, brought in a concept called adaptation pathways. There's a British standard with a link on this slide, which you'll see in the PDF that you'll receive after this presentation. It's a British standard that looks at adaptation pathways and how that can be used to deal with uncertainty. And adaptation pathways is all about making interventions, knowing what you know, and not getting in the way of an intervention in the future, and looking at different stages, maybe 20, 30 years apart, where things can be modified to suit the emerging certainty in some of the science, but also dealing with the uncertainty. So where we've got changes in climate and you want to design something to be there for a long time, it's best to think, in my view, to use something like adaptation pathways. So you design something for maybe 30 years and then build in changes incrementally over time. Some of those changes might mean transformative change, which essentially means relocating the asset. If you've got an asset that's going to be compromised frequently in 20, 50, 100 years' time, you might want to move it and make arrangements to move it. Certainly in the west of the UK, in Wales, there's a couple of towns on the coastline that are going to have to be relocated in the next 100 years because sea level rise will make living in those towns untenable. And the last one here, an opportunity, is build back better after something's been damaged. Don't just build back and put back what was there. Build back better. Think of the future climate. That's an opportunity. Future-proof the whole system. So some last thoughts on adaptation before I go on to a few case studies. Think about systems, think about criticality. Think about the interlinkages between different infrastructure systems. 1490 recommends using systems thinking to scope the adaptation plans so all areas are addressed, like the long supply chains, like thinking in terms of uncertainty and how to deal with uncertainty using adaptation pathways, prioritizing on things that are most critical. Good planning practice, touched on this already. Look at planning laws, reduce exposure to hazards, think early on in project phase. So as you design things with long life, whole life value in mind, not cut costs and make things cheap to build, but expensive in the long term to maintain. Capacity building, Paris mentions the adaptive capacity concept, and using tools like CAD. There's a link to CAD, that's capacity diagnosis and development. That's one of the tools that we use in Climate Sense to look at the clause 5 pre-planning concept, and monitoring, evaluating, making the right changes as an adaptation plan develops over time. Be able to change it when new information comes about. It's linked in as well with the adaptation pathways that I mentioned. Make the best use of existing design codes, but adapt them to suit local and future conditions. You can be compliant with the design codes that might look at past climate. You can make them more relevant for the future climate using climate data that is available, and adapt them to suit local and future conditions. Don't blindly follow them, whether they're past weather hazards and weather parameters. Look at the future. And there's a few more here as well. Next steps, mainstreaming. Build infrastructure can be adapted at a future date. Adopt a line of sight throughout workflows from heads of agreement to delivery and maintenance of a project. Think systems and criticality. I've mentioned that. Good practice and spatial planning. Build capacity. Monitor and evaluate. Make the right changes and make the best use of design codes. I mentioned the structural Eurocodes. They've got a concept that has a national annex for every country, which gives us the opportunity to insert future climate parameters suited to any country. So there's a concept there that's been around for a bit, and that's the way the structural Eurocodes are being developed over the next couple of years. So just have a short drink.
John, just while you're pausing here before the case studies, just a quick update on the time. We have about 35 minutes left, just to want to leave some time for questions at the end as well. Right. So 15 minutes for questions, 20 minutes, whatever, however many case studies you think you can fit in.
Well, I'll rattle through one or two of these. I won't do them all because they'll be there in the PDF, but I'll just pick up one or two then, if that's all right.
Perfect. Thank you.
Yeah. Well, I'll start with Transport Canada, of course. Transport Canada has been incorporating elements of 1490 as part of its adaptation activities, and some key staff have undertaken training on 14,090. And there's a link there that we offer training courses around 1490. A couple of years ago, I was involved in a bit of work with the University of Birmingham, looking at a policy guide for low-income countries on climate resilient transport, mainly for African and South Asian low-income countries. But the ISO 14090 framework was used as a core structure in asking questions and analysing the capability of existing policies. It was highly praised by the project group that steered that work. The UK rail regulator have used 14,090 as a framework to examine weather resilience and climate change adaptation plans in Network Rail, which is the infrastructure manager for rail in the British mainland. So 14,090 was seen as a very good framework to look at what was being done. The International Union of Railways, and sorry, this seems very railway focused. I'm a railway person, but I've got one or two other things as well. UIC used 14,090 as source material for this guideline on adapting the railway to the future. In Canada, the Public Infrastructure Engineering Vulnerability Committee have got applications, refers to having applications compliant with ISO 31,000, which is the one on risk management, and 14,090. So, these are all very sort of high-level policy guidelines that it's the way to start. If it starts at the top level of the governance chain and the sort of regulatory chain, then it filters down, and 14,090 gets used more and more by people at ground level. Again, the First Nations Infrastructure Resilience Toolkit cross refers to the PIEVC work, which again refers to 1490. And a couple of other things. This is a diagram here of 14,090 with supporting documents, 14,091, 92, ISO Guidance 84. I chair the strategy group for ISO on adaptation, and we're thinking of bringing in BS 8631 on adaptation pathways as an ISO, given the right sort of time to modify that. That will happen in a year or two, and other standards are coming in the same family. The European standards body talks about infrastructure designing for future hazards, and I've said before that most of them are anchored in the past climate. There's been a mandate on infrastructure standards in Europe to look at changing some of these standards. But I keep coming back to this point that client organizations can require design for future climate now by using the right parameters. And SEN has got a tailored guidance for helping standards writers in getting the right data. There's a link there to that. And ISO Guide 84 also has some guidelines for standards people to look for where the right data is for adaptation and for greenhouse gas emissions. Both these documents are free documents for addressing climate change in standards. Just for my own company, Climate Sense, we've got training packages with a link here, virtual delivery of training packages around ISO 14,090. And there's a whole series of different things we do in Climate Sense. So when you have some time, you can look at this and look at our website and see the sort of services we offer. Things like rapid adaptation pathway analysis, capacity development, the clause 5, fitness for doing adaptation planning, that sort of thing. And we're building in things like TCFD into our training as well over time. So I think that's about it. Oh, here's some of our clients, a nice picture of some of our clients' logos who've worked with us over the past few years. I think that's it. So Claire and Laura, I'm passing back to you. I shall stop sharing and see
Wonderful.
if we have any questions.
Yes, thank you. Yeah, so we have about 30 minutes left for questions, so perfect timing. We have a few questions already to get started, but I'll just invite anyone else, if you have questions, please add them into the Q&A box now, and we'll get to as many questions as we can in the time that we have left. So first question, I've been looking for guidance for designing and constructing infrastructure on thaw unstable permafrost for a long time, and the sense of defensible design life and level of service for thermal modeling. Recognizing that infrastructure routinely remains in service well beyond its initial design life, what thermal design life should engineers use for design?
That's a really good question that kind of picks up on the comment I was making about adaptation pathways. There's so much uncertainty around sort of thermal profiles in the future that I think an adaptation and pathway approach would be quite a good one to look at. And of course, it would be the sort of thing where you bring experts together and work out how long that you would have sort of valid parameters to work with and be able to design for a period of time, and then think about what changes you might need to bring in. Not forgetting, I think, that it might be the sort of dramatic option of abandoning a site and moving somewhere else or doing something completely different, because we can't get away from transformative adaptation if the problem that faces us is so complex that we need to do something like that. But again, I think it comes back to what sort of timelines are you thinking about? Can you actually design and build something or maintain something effectively through that time span? And if not, it needs to bring about, you need to think about a different way of doing it. Or you might be able to sustain something for a while, knowing that sometime in the future you have to make a decision that changes where you're going. It's the point I would make is that you probably wouldn't be able to think about having sort of 50-year life of a project. It might be much shorter than that. And that's where the adaptation pathway concept kicks in. That BS8631 link explains that process. It's a 9-step process that could help in that. I hope that's helpful.
Wonderful, thank you. Next question. ISO 14090 is a potentially certifiable standard. How do you see that playing out in the market?
I think it certainly is something that is potentially certifiable. It needs organizations to ask that question. Can you prove that you've used ISO 14090 for an adaptation plan, that sort of thing? And it depends on what sort of organization would want to do that. We've had discussions with some multilateral investment banks about this concept of accreditation to 14090, and some of them see it as a powerful tool to make sure that sort of agreements early on in a project about making things climate resilient are proven to be climate resilient by using the standard. So it depends, I think, really on the players in the market to look at how this standard can benefit them if they have this need to prove that, for example, a 20-year loan is going to be paid back because the project has been delivered in line with 14090.
Right. Okay, thank you. Which countries follow similar approaches to ISO 14090?
Which countries have similar? I can't really answer that. I know it's been we've had inquiries in my company from people who are wanting to look at training to 14090 from the Far East, from the Philippines, from Korea. We also know that in France, it's something the French government have been thinking about enshrining in law, and one or two other countries are picking up, like Transport Canada have been doing some training. We've looked at we've trained people who are looking at human rights who are based in Germany on a global perspective, and it's one of these things actually that it's difficult to say who's actually using it, because the way that ISO monitors where the standards have been sold isn't actually an easy to analyze process. So I'm not sure where it's been most popular, the standard. What I am sure of, though, is that we've kind of got caught out because we launched 14,090 in the summer of 2019, and in 2020 we had COVID, and everybody's attention went somewhere else. And it's only now, I think, in the past sort of 6 months that things like this webinar and other inquiries been starting to ramp up again. So sorry, I can't give a really straight answer to which country uses the standard.
Oh no, that's great. Well, just building off of your last point, one of the questions is, could 14,090 be made publicly available as a publicity moment that emphasizes the importance of climate adaptation to the global community and all its systems?
That's what I would like to see. There have been sort of discussions in ISO around that sort of topic. ISO actually made quite a few standards relevant to battling COVID available for free, and some of us are lobbying the ISO Central Secretariat, the sort of governance in ISO, about making ISO standards freely available, because this topic is so urgently needing dealt with. And that's a really great question. It's something, if I had control over it, I'd say yes, make it free. It's a vital thing to have, and it's something that some of us have been speaking about. And if any of you have influence who are listening just now, write to your national standards body and ask them, if the Standards Council of Canada, people like that, say, why aren't these things free?
Next question, do public procurement processes that focus on the lowest acquisition cost hinder the inclusion of adaptation and resilience measures in new infrastructure?
I would say yes. I think when you talk about lowest acquisition costs, it depends how that sort of term is interpreted. If I interpret it as saying that we're building something, but we want the lowest first cost, then that to me is the enemy of redundancy and resilience, because the lowest first cost can mean you get unintended consequences like infrastructure that's not maintainable, infrastructure that's not resilient to future climate, infrastructure that doesn't actually last a long time. We need to get into that mindset, like I was talking about in these slides, about looking at whole life value, not lowest first cost. And when we're sort of justifying a project, the project should be looked at over its whole design life at least, but also with a view to how you can extend that life over time. And the other side to that as well is thinking about building something now. You might design it for a fatigue life that takes so many vehicles over a bridge, say, that might last for 100 years. But when talking about climate, we need to use this adaptation pathway approach, which might look in 20, 30, 50-year bites, and building something now that could be retrofitted in 20, 30, 50 years to make it more robust for long-term future climate. Huge challenge in some ways to do that, but it's making passive provision for future climate to have the first cost reasonable, but the intervention cost being reasonable as well. Different mindset. But, I'm an engineer, and I think this is a sort of challenge that engineers can rise to and build things now that can have that passive provision for changing the future. Maybe an example I could give there is if you've got a sea defense or a river defense that you build to the known sea level for maybe the next 50 years, but have the foundation strong enough to raise that defense meter or 2 meters in 50 years' time. And you can think of similar sort of concepts for things like, it's not transport, but high-rise buildings. If you don't know what the wind profile is going to be in 50 to 100 years, then you build the central core of a tall building in such a way you can strengthen it in 50 to 100 years for a different wind climate. Engineering challenges, they can be solved.
Right, thank you. Do you think there is a problem with getting the executive cadre to consider and correctly weight long-term risks in their planning rather than the in-your-face? For example, project reputational risks they are used to dealing with through their corporate risk register.
I don't quite understand that.
I
question.
think it ties back to you were talking about kind of getting senior management on board, and how do you get them to like consider adaptation in a way that they're maybe considering other risks that don't have to do with resilience.
Yeah, I think it's probably around the sort of concept that senior managers just now have a short time frame. You know, I'm a director of a company, and the company's business maybe looks a year or two ahead. And if I'm only looking a year or two ahead, I couldn't care less about what happens in 20, 30, 50 years' time. But in terms of climate risk, we need to look 20, 30, 50 years' time. Someone has to pick up those pieces. And there needs to be some sort of corporate culture that recognizes that brings that thinking into the organization. So as future reputation, future risk is factored into the corporate risk register. I've seen incidents in various places where the corporate reputation has been the thing on the line rather than physical risk affecting people's safety, that sort of thing. From weather events, there was an incident at a major airport, Gatwick Airport in the UK, I think about 10 or 12 years ago now, when on Christmas Eve, the power systems went down because of flooding that affected one of their own substations. And nobody was hurt, but the reputation to Gatwick Airport not being able to get flights away on Christmas Eve was hugely important. And the company took another view as to how important its drainage maintenance activities were because of that. Simple things. You couldn't flush toilets when the power went down because all the toilets were reconfigured to have those sensors you move your hand in front of. And tremendous bad reputation really impacted that company that ran Gatwick. How you get that sort of long-term thinking into the mindset of company directors is all couched in with governance and social responsibility and all these other areas that need to be factored in. It's a huge challenge because people are very short-term what they look at. But to make those changes, it would probably have to come about through something like legislation to make sure these long-term things are thought about, like TCFD, you know, looking at financially related climate disclosures and so on. Some bodies are around that can bring that thinking into organizations, that long-term thinking.
Mm-hmm. Right. I think this next question ties into that. The best strategies or plans would be ineffective without extra budgets. How can we convince our lawmakers to supply the necessary money to improve our infrastructure?
It's a case of analysis. It's a case of challenging the economics. It's a case of picking up on things like the World Bank's point. You know, for every dollar invested, there's $4 return in resilience building. It's picking up things like that. Those sorts of phrases, those sorts of buzzwords, I think. But it's also the case that if we don't invest in resilience now, then what will the future look like? We're not going to have robust systems. We're not going to be able to deliver transport in the way we are now. So there needs to be some analysis of that as well to show the case for making that investment. But again, I come back to the comment I made about challenging the economics, because the economics based on relatively high discount rates and maybe 20 years in the future, and which means that future generations can afford more than we can now. Put that to one side, because we need a different way of looking at the economics in terms of climate resilience. We need triple bottom line. We need, and you know, I keep saying that, but I haven't got a way to influence that. We need some of these decision makers to think long term and think about return on investments with a resilient transport system versus one that isn't resilient. And if we don't analyze things in terms of adaptation pathways, for example, we won't be able to sort of develop long-term strategies and plans that are robust and resilient. We need to use these tools like adaptation pathways, look at the uncertainty, carry out. I mean, one of the comments in 14,090 is about using tools like multi-criteria analysis to justify investment in future resilience. And I've seen sort of case studies using MCA to justify investment in resilience that actually make quite a difference to the base case for that investment. So there's lots of tools out there. Being creative, we can look at those and justify budget for future rather than say, oh, it's too expensive. And again, expensive is a subjective term. What's that related to? If you think it's expensive now, wait 10, 20 years. Do you want to find out? You need to do something, experiment, study, research, and actually work a different way of proving that you need to invest this much now to provide that benefit in the future.
Right, thank you. I think we just have one more question left. Does ISO 14090 include an audit process?
It doesn't. No, we tend not to include audit processes in standards because there are plenty audit bodies out there, accreditation bodies, who will be able to take up a standard and work out how best to go about auditing it. There's a number of requirements clauses in 14,090, the ones with the word shall. And I mean, having been involved in standards audits in the past, I can take 1490 or any standard and ask questions around those requirements of an organization to say, this says you shall do X, Y, Z. Show me how you complied with that. The difference, I think, in many ways in 1490 to some other standards is that some of the requirements are looking to the organization to go and do something particular to that organization or particular to adaptation, which might require a level of expertise in adaptation to say that their answer to an audit question is valid or not. But that's something that's faced in other standards too. I'm sure the market would find a way to assess an organization, say, yes, they are compliant with these parts of 14,090.
Thank you. We just have one more question come in. How does ISO 14090 interact with the Envision framework? I'm not familiar with that framework. I'm not sure if you are.
That's one we can take away. I'm not quite familiar with the Envision framework. Maybe I should be.
I'm not either. Okay, yeah, we'll take that one away then. Okay, I'm not seeing any more questions. So maybe I'll just ask if you have anything you wanted to say in closing, John, and then I can. Apparently, Envision is a sustainability rating system. I'm not sure if that helps or if we'll just leave it there for now.
Well, I mean, I get involved in some rating systems, and I'm not sure if Envision is one like I've used before, but if it requires people to prove that they've been looking at resilience and adaptation, then 14,090 is one of those standards that could help with that. But in closing, it's been a real privilege to speak to. I think we've got 110 people online. I think nearly 300 people registered for this. It's been recorded, so I'm really grateful. We can use this technology to spread this message, and I'm really pleased to hear those questions, and really good questions, and to be able to sort of push the word around about ISO 14090 and its role in delivering adaptation. I will ask one thing though, if any of you want to get involved in adaptation standards, please do speak to the people at the Standards Council of Canada, or I know there are people from across the globe here as well. Your national standards body, we really need more people to get involved in adaptation in standards, because too few of us, there's not many of us. We struggled to put together a group to produce 14,090. There's many more people now than there were 5-6 years ago when we started on this, but I'm very keen to get people from the least represented groups involved from the global south, from Indigenous people as well involved in adaptation, because in some ways I think that I've helped to put together a document that's maybe centered on the West and our expertise, but we pushed that out there. Next year, we're going to review the standard. And if there are things we need to introduce to help adaptation go to a wider audience, and there's an opportunity there for others to help out in becoming maybe a member of a national standards body adaptation group that can provide input. But that's really all I wanted to say. A plea for help, and thank you for listening, and some lovely comments in the chat there. Thank you all.
Thank you so much, John. We really appreciate you coming to speak to us and for that great presentation. Before we close out, I just want to note that we have 2 more upcoming webinars in March, one on strengthening climate resilience for aviation organizations, and one on understanding and using the latest climate data to build resilience in the transportation sector. So if you want to register for those upcoming webinars, the link should be in the chat now. And we will also be sharing a link to a survey so we can learn how to improve our webinars that we would greatly appreciate your feedback on. Thank you again, John. Thank you again, everyone, for joining us today, and I'll wish you a great day.
Thank you.